Welcome class 12th students. Today in this part we will discuss adsorption isotherm. Adsorption isotherm. The extent of adsorption of a gas per unit mass of the adsorbent depends on the pressure of the gas. If we are talking about the extent of adsorption, then the extent of adsorption of a gas per unit mass of the adsorbent, it depends on the pressure of the gas. And the variation in the amount of gas adsorbed by the adsorbent with pressure at constant temperature can be expressed by means of a curve termed as adsorption isotherm. And the extent of extent of adsorption can be expressed as x by m, where x is the mass of adsorbate and m is the mass of adsorbent. So x by m, the whole term, is known as extent of adsorption. This can be seen with the graph also. If we are draw a graph with extent of adsorption x by m with pressure P, we will see that on increasing the pressure, the extent of adsorption gets increases. But at certain time, at certain point or at certain pressure, on increasing the pressure, the extent of adsorption now remain constant. Since we know that adsorption is a reversible process, as the adsorption starts on the surface of the adsorbent, after some time, after some pressure, as the extent of adsorption is maximum, after some on applying some pressure, the desorption of the gas molecule also takes place. So adsorption is a reversible process. The amount of adsorbate molecule adsorbed on the surface is equal to the amount of dissolved adsorbate from the surface. So that situation, on applying the pressure, the extent of the adsorption now becomes constant, and that point when adsorption equal to desorption, that point is in equilibrium, and that point is known as saturation pressure here. So this is the adsorption isotherm. The concept of adsorption isotherm was further explained by the scientists, and one of the scientists is there that, who is Freundlich, and he discovered Freundlich adsorption isotherm. Now come to Freundlich adsorption isotherm. Freundlich in 1909 gave an empirical relationship between the quantity of gas adsorbed by unit mass of solid adsorbent and pressure at a particular temperature. It means temperature remains constant. From the graph of adsorption isotherm, the following observation can easily be made. At low pressure, since this is the graph of adsorption isotherm, so from at low pressure, as we are assuming low pressure this side, the extent of pressure, the extent of adsorption, that is x by m, will directly proportional to the pressure, as we are talking about this region where the pressure is low. So at that time, the extent of adsorption x by m increases with increase of pressure. It means x by m is directly proportional to pressure P. And as we remove the proportionality sign, we get a constant, that is K. So x by m equal to K into P pressure, where K is constant. From the same graph of adsorption isotherm, if we are talking about at high pressure, so at high pressure the graph becomes almost constant. As we can see in the graph of adsorption isotherm, at high pressure the graph becomes almost constant, which means that x by m, extent of adsorption, becomes independent of pressure. It means the value of x by m now equal to a constant term. And if we are talking about in between the intermediate range of pressure, if we are talking about in between low pressure and at high pressure, the middle term of low and high pressure, if we are talking about intermediate range of pressure, then what will happen? That amount, that extent of adsorption x by m will depend upon the power of pressure which lies between 0 to 1. In that case, when we are talking about intermediate range of pressure, then x by m will depend upon the power of pressure which lies between 0 to 1. So x by m will be directly proportional to p to the power 1 by n. Or on replacing this proportionality sign, the constant term will be here and x by m will be equal to k p to the power 1 by n, where n can take any whole number value which depends upon the nature of adsorbate and adsorbent. This relationship is called as Freundlich's adsorption isotherm. This relationship is known as Freundlich adsorption isotherm. Now from the relation of Freundlich adsorption isotherm, calculation of constant K and N of adsorption isotherm. Since this is the equation x by m equal to K p to the power 1 by n. Now for this equation, taking log on both sides, we get log x by m will be equal to log K plus 1 by n log P by using the property of log here. Thus, if we plot a graph between log x by m on y-axis and log P on x-axis, a straight line will be obtained. Now this will be the graph for the Freundlich adsorption isotherm if we are plotting x by m in y-axis and log P in x-axis. So we will obtain the straight line here, and this straight line has the slope of 1 by n and intercept of log K. Since this equation is quite similar to y equal to mx plus c, in which m is slope and c is intercept, which is a constant term. Similarly, here it is log k will be the constant. Log k is a constant term, so it is an intercept, and 1 by n is slope here. So the slope for the curve is 1 by n and intercept is log k. Come to the next. Adsorption can also be formed for solution. So adsorption from solution. The solids can adsorb solutes from solutions also. Suppose when we have a solution of acetic acid in water and that solution is shaken with charcoal. We have a solution of acetic acid with water and that solution is shaken with some charcoal particles, some charcoal molecule. Then a part of acid is adsorbed by the charcoal and the concentration of the acid decreases in the solution. It means some solute particles from the solution can also get adsorbed by some adsorbent. From this, the following observation have been made in case of adsorption from solution phase. First is the extent of adsorption decreases with increase in temperature. Second, the extent of adsorption increases with increase of surface area of the adsorbent. The extent of adsorption depends on the concentration of the solute in the solution, because the solute is getting adsorbed on the surface of adsorbent here in this case. And the extent of adsorption depends on the nature of the adsorbent and adsorbate as well. That extent of adsorption will also depends on the nature of adsorbent and adsorbate as well. So Freundlich's equation approximately describes the behavior of adsorption from solution with a difference that instead of pressure, concentration of the solution is taken into account. That is, on replacing the pressure term from the Freundlich equation, here we will replace pressure P with the concentration C. So x by m will be equal to K C to the power 1 by n. Or on taking log on both sides, log x by m will be equal to log k plus 1 upon n log c, where c is concentration of the solution, concentration of the solute. Or from this equation, the graph for the adsorption from solution is also similar to the graph of the as we draw the graph for Freundlich adsorption isotherm, here in y-axis it will be log x by m, and in x-axis it is log of concentration. In place of pressure, here concentration term will be replaced, and a straight line will be observed. The slope of this line is 1 upon n, and the intercept for this graph is, slope of this graph is 1 by n, and intercept for this graph is log k. So thank you. That's all for today.